Well, hey, Algebra 1, this is a strange way to be meeting with you, but it's what's going to have to be sufficient for the next few weeks until maybe we can get back to some semblance of normality. So, if you will, get on your Google Classroom and you'll see an announcement, basically a remote learning syllabus that I've put together for you. It goes through the details of how you can get your work and how you can send it back to me. And I'll leave that. Y'all can just read that and look at the details there. So one of the first things we're going to do, and you're going to get a grade in the grade book for it, so I want you to be sure and do that. You had this worksheet, quadratic equations, before we left for spring break. You did the front, and it was required that you finish the front before we left. So if you need to pause this video and go get that sheet, go ahead and do that. If you aren't able to locate it, if for some reason you left it here at school and you don't have access to that worksheet, I've put a copy of it in your Google Classroom as well, so you can go ahead and maybe run off a copy of that or be looking at it, at least in writing down your work on a separate sheet of notebook paper if you can't make a paper copy of that. So what we're going to do is finish this, and I asked you to do the front. You did solved quadratic equations. 2 were by factoring, 2 were taking the square roots, 2 were completing the square, and the last 2 were using the quadratic formula. So I tell you what to do. I think I'm going to just kind of swap over to the document camera. The first few were pretty simple. I don't think I'm going to necessarily walk through step by step of each one of those. So allow me to put that on the document camera, and then we'll kind of pick up in the rough spots. So here we go. I'm going to make that swap now. So here at number 1, we wanted to solve by factoring, so we just made sure we got this side equal to 0 by subtracting that, or excuse me, adding that 18x. It wasn't like terms, so it just had to slide in here in its correct position in the standard form, x squared, then your x to the first, and then no x's. This one was a pretty easy one to factor, but it was unique in this regard that both of the x's would have had to be -9 for one of those binomials to be equal to 0. So because of that, there's really only one root or one answer, and that was x equals -9. In this one, again, we had to get it equal to 0 by subtracting the 15. Again, it had no like terms, and so we just shifted it down here to the end where plain integers go. This had a coefficient, so I had to break it apart into 2x and x, and then the factors ended up being 2x plus 5 times x minus 3. This one was fairly simple though. I mean, for this binomial to be 0, x would have to be 3. 3 minus 3 would be 0, so x could be 3. This one, if you can apply that mental math to do that, you know you'll have to subtract 5, which will make it a -5, and then you'll have to come back and divide by this 2, so it's going to be -5 over 2. If mental math was a struggle, you can always take 2x plus 5 equals 0, bring it over here to the side and work through it, and you'll get that same answer, -5/2. And of course, you know, I'm fine with -2.5. Answering in a variety, either decimal or fraction is fine. Down here, when you get to number 3, then we had a different route that you were asked to take to actually take the square root. And your first step there was to get x squared by itself so that you then can take the square root of it. So, of course, we need to get rid of this 3. It's being multiplied to the x squared, so we'll divide by 3. That gets us x squared equals 16. And then we want to unsquare the square, so we take the square root of it to kind of undo that, and they'll cancel one another out. This radical symbol and the square raised to the second power cancel one another out and gets us down to just a plain x. But keep in mind, kind of that new thought that we had to be thinking, not only does 4 times 4 equal 16, but also -4 times -4 could be that value that would give you 16. So remember, that's how we display our answers, plus or minus 4. So there's kind of those 2 roots, the way we had the same, 2 solutions or roots there. What I want you to do is look at number 4. Up to this stage, you're going to divide both sides by 20 just to get us here. And then when you take the square root of both sides, you're left with the answer in this format here. Now what I'm going to do is freeze the screen, and I kind of want to show you, not kind of, I definitely want to show you how to take that just a step further. You get a little blue ink going here. You can extend this answer on to be something more. And there's another way of displaying this very same answer. When you have this square root symbol, remember it has a name, it's called a radical. And when you have a value underneath a radical, you can simplify it further. It says I have an eraser, but it is a marker. So the square root of 250, I'm going to write that again here. The square root of 250 can be broken apart if the number under the square root can be factored out, and maybe you'd have a value that is a square root. I happen to know pretty easily by mental math that 250 is really just 25 times 10. Write that down with me as you work with me. And then, so if I take the square root of 25 times 10, then I can take each one of these and break them apart and put them under their own radical. It would look like this. You have the square root of 25 times the square root of 10. So you can bust those guys apart and give them their own little square root house, their own little radical to dwell under. Now this one can be simplified. 25 is what we call a square number. Something times itself, an integer value times itself would give 25. So we know that would be plus or minus 5. So plus or minus 5 times the square root of 10. You don't have to put the times symbol. It's understood multiplication still going on here. And so this is another way of displaying this very same answer. So you can display plus or minus the square root of 250 or plus or minus 5 times the square root of 10. You know, you can also grab your calculator and just type in, hey calculator, I want the square root of 250. It'll do that for you. I'm going to go ahead and grab my answer sheet. If you just key this straight into your calculator, it'll tell you that the answer is like 15.811 something, something, something. It goes on a long way. We've made a classroom pact of saying, hey, let's just always round to the hundredths place if we've got to run on decimals. So really, rather than saying that it's exactly equal to, I could instead say, well, x is about equal to. Remember, that's kind of like this little wiggly equal sign. It just means it's close to it. It's an approximation. So it's about 15.81. Oh, excuse me, plus or minus 15.81. So if you look at it, there's 3 different ways of displaying that very same solution. Here, here, or here. Now these 2 are definitely the easiest. That's a little bit of a set aside or new lesson for you right there. Okay, and hope you don't have any misunderstandings with any of that, and I'm going to go ahead and kill this frozen shot and bring the paper upward, and we'll work from there. I think I'm going to go ahead and bring this document up. All right, so by completing the square, remember, you want to have all of your x's on one side and your plain integer values on that other side. So the first thing I want to do is add 6x to both sides. And just leave that 40 hanging right there. And we'll have x squared plus 6x. And remember, what we want to do is leave a gap. And we're going to fill that gap with a number that allows me to have a perfect square. Something that I can factor. And so remember that the best way of doing that is to take this b value, cut it in half, and then square it. In your notes, it looked like this. We're going to take the b value, half it, and then times it to itself. So half of 6 is 3, and 3 squared is 9. So I'm going to change ink colors to remind myself that if I add 9 to that side, I put it in red ink to remind me, now don't forget, you have to do the same thing to this side or it's no longer equal. I can't just randomly add 9 to one side without adding it to the other. And what that provides is this solution. We've got 49 over here. And now this is factorable. It's going to be x and x, of course, to give us x squared. And the factors of 9 are either 9 times 1 or 3 times 3, but only one of those sets will combine together to give me 6, and of course that's the 3 and 3. And we'll put pluses on both of those. Okay, and so from there, what we said we would do is, well, we could rewrite this, since that is a binomial times itself, we could just say, well, that's x plus 3 times itself, squared, and that's equal to 49. And then we can unsquare it just like we did in an earlier problem, except instead of just x, it's x plus 3. But I'm going to take the square root of all this, which means I'm going to take the square root of that. And this square root symbol cancels out this square, leaving me simply the x plus 3. Whatever's under the radical is what you're left with. And this will be plus or minus 7. Plus or minus 7. And then to solve for x, I have to get rid of the plus 3. By doing that, I'll just minus 3 from both sides. And so what you have left is x is either positive 7 minus 3, that would be 4, or x could be negative 7 minus 3, which would be negative 10. And there's your two solutions for this problem, a positive 4 or a negative 10. Now number 6 was a tougher problem, and it also involves something that I don't believe I had shared with you yet. So one of the things, again, that we want all of our x's and x squares over here and our plane numbers over there. So you need to add this 5 to both sides. And since all I'm doing is adding and subtracting right now, and they're on the same level of importance, I'm going to go ahead and allow you to minus the 8x from each side also. We'll just kill a couple of birds here with this one stone. That leaves me a positive 5 over here. The 5 is now gone from this side, but what's left is this positive 4x squared minus 8x. And again, we'll leave the gap. Now here's what I had not yet shared with you, and would have if we'd have been back to class, is that completing the square only works if your a value is 1. A needs to be 1. I'm going to write that right here. A must be 1. That's an important note. It's not going to work out for us if this remains 4. So for that to happen, I need to do a couple of things. One of the things that I could do is factor out a 4. I guess we could kind of look at that right now. If I factor out a 4 from this before I get busy doing the rest of it, factor out a 4, because they both have a 4 in common. And that would leave 4 times x squared would give me this 4x squared, and 4 times negative 2x would give me this negative 8x. And now I want this x squared to be left. I don't want this 4 here anymore, and so I have to have an a value of 1, not 4. And so I'm going to just divide that 4 out. What I do to one side, of course, we got to do with the other. Now, I'm going to admit to you right now, this is an ugly looking booger, but we can do it, so be sure that you're working along with me. So we have x squared minus 2x equals 5/4, and you're welcome to just leave it in fraction form. Don't be tempted to put it in like, 1 point, what would that be, 1.25. You can just leave it like this. All right, so now here is where I actually need to leave that gap. So I'm going to grab this and scooch this stuff over and leave ourselves that gap. Because now that I got this down to 1, I'm ready to complete the square. And so when I complete the square, I need to take half this value, which would be negative 1, and then times it to itself. Negative 1 times negative 1 would be positive 1. So I'm going to add 1, and again, I'm going to do it in red ink to kind of stand out to me. What I do to one side, I have to do to the other. So we have this right here. This will now factor out to x minus 1 and x minus 1. If that's positive, these sides are going to both be the same. But since it's going to be, x minus 1 times x minus 1, something times itself, here's our inner and our outer products to create this center value here in this quadratic. This is definitely going to work. But I tell you what, to speed myself up, instead of writing it like this and then going to this step, I'm going to go directly to this step and just write it one time and put a square on it. So I'm going to back that up a little bit. It's definitely x minus 1 times itself. So x minus 1 squared is equal to, now right here I'm going to kind of throw you back to some earlier, probably 5th and 6th grade multiplication, or not multiplication, but working with fractions. So 1 can be disguised, since I'm working with fourths, I could disguise this 1 as 4/4, and I'm going to do that so I'll have like terms and I can combine. I can't combine fourths to anything but more fourths, So that 1/2 I'm going to rewrite as 4/4. So what I have on this side is really 9/4. Now, if that blew your mind, if it's been too long since you've done that, you can always take your calculator and say, hey, calculator, protect it with parentheses now, and say 5/4 plus 1, and, you know, the math 1 enter. If you hit math 1 enter, it turns it back into a fraction, and it'll tell you 9/4. So if you need some help with that. Okay, and so now it's time to take the square root of this side, just like we did over here. We took the square root of it once we had to that space. Now I'm about out of space here, so what I'm going to do is carry on right there. So I've got this x minus 1. I'm just going to take this work and head right up here with it. We've got x minus 1 in parentheses, and we're squaring it, and right now it's equal to 9/4. Now hold on to your pencils real tight. You can get through this. We're going to square root each side. You're learning a lot today, they're pretty understandable details, but you're learning some new things about how to handle radicals. And so remember, the radical undoes this square and leaves me with simply x minus 1. And again, either with multiplication or with division, I can go ahead and split these guys apart. I can refer to this as the square root of 9 over the square root of 4. So the square root of 9 over the square root of 4. So we'll bring that down. And of course, the square root of 9 could be plus or minus 3 over 2. So 3/2. And I'm almost done. To get x by itself and to solve for x, I have to add 1 to undo this. So we're going to add 1 to both sides. And that will result in this. And remember, here's your two different roots. First, you'll take the positive of it. Positive 3/2 plus 1 would be, remember, that's 2/2. So 3/2 plus 2/2 would be 5/2. And you can use your calculator. You can just say, hey, calculator, positive 3/2 plus 1, math 1 enter, and it'll tell you 5/2. Or if it's negative 3/2 plus 1, which again is the same thing as 2 over 2. So negative 3 over 2 plus positive 2 over 2 would just leave a negative, or x could equal a negative 1/2. So here's your two solutions there. All right, I know this is getting to be a long video, but it just takes a while to go through all this stuff. Again, I'm going to kill this frozen shot, move it forward. You can always take the video and back it up and take a look, a slower look at each one of these things. All right, so right here we're going to use the quadratic formula. And the quadratic formula was on your formula charts. You can access it. If for some reason you don't have your notes with you, you can always look up the quadratic formula. Just Google it. Y'all Google everything else, so go looking up that quadratic formula. So the quadratic formula, first I need to have this equal to 0 for you to apply the quadratic formula, because remember, with the quadratic formula, you have to have it in its standard form, which is ax squared plus bx plus c equals 0. That's the standard form, because you're going to need those a, b, and c values to substitute into your quadratic formula. So you do need to get it equal to 0. That means we're going to minus 6x and add 2 on both sides. Minus 6x and add 2. And that cancels it all off of here. We do have it equal to 0, and I'm going to write this in standard form. Scooch it down. You got 3x squared minus 6x plus 2. And so, if you'll recall, I encouraged you to go ahead and copy down your a, b, and c values by looking at it right here. So your a value is 3, your b value is negative 6, and your c value is positive 2. And then we can apply the quadratic formula. Now that quadratic formula, you remember, if you try to go straight to your calculator, it's a lot of using parentheses that you may or may not be, there's a lot of room for error, we'll say that. And so it was to our benefit to work down as far as we can by hand, then we'll let our calculator kind of help us out. And so the quadratic formula says, all right, x is this. It's the opposite of b, so that would be 6, plus or minus the square root of b squared, so that's negative 6 squared, and I always bring those in parentheses. Negative 6 squared minus 4ac, so 4 times a, would be 3, times c, which is 2. All of that over 2a, so 2 times 3. Okay, so we're just going to kind of keep on solving here. I know there's not a lot of space here, so if you wanted to go to notebook paper, you can definitely do that. So we have 6 plus or minus, and now the first thing we want to do is simplify everything under the radical. So here's where the calculator might come in handy. You could just literally start keying in right here. Don't key in the radical, just key in negative 6 squared, negative 6 in parentheses squared minus 4 times 3 times 2, and have it spit out a single value for you. If you do, it's going to be 12, because this is negative 6 times negative 6, of course, is 36. I'm going to do some mental math here. Negative 4 times 3 is negative 12. Negative 12 times 2 is negative 24. And all of this is over 2 times 3, or 6. I'm going to go this way just a little bit to kind of conserve my vertical space. So I have 6 plus or minus the square root of 12. That's what you get. 36 minus 24 is 12. All of this over 6. Now this is where you want to pick up your calculator, because the two roots or two solutions for x are going to be one using the plus sign, and then your other root would be using the minus sign. So on your calculator, if you typed in 6 plus the square root of 12 over 6, you can actually do that. You could say, well, one root is 6 plus the square root of 12 over 6. Now remember, 12 is one of those numbers that I can split apart. I could split 12 into 4 times 3, and 4 does have a perfect square root. That's really plus or minus 2 square root of 3, if I put that under the radical. But I'll be honest, right here at this point, it's probably simpler just to take this route right here. So we can write it once with the plus sign, and then I could have my or x would be equal to 6 minus the square root of 12 over 6. If you want an approximation though, you key that in and ask your calculator to hand that to you in a decimal form. It's going to be, this side's going to be about 1.58 if you round, I think. Pretty sure that's right. I'm looking at an older key, but I think that's going to be right. I have actually written 1.577, but that the second 7 would round this first 7 up to an 8. And then the other value here, x could be equal to a 0.42. And again, it's not exactly equal to, it's about equal to, so we'll put those wavy equal signs in. And there's the two roots. This method right here is it's in perfect non-rounded values. But if you are called upon any kind of test format to round it to the nearest hundredth, just key that into your calculator. Now remember, on your calculator, if you're going to key this in, you have to protect this complicated numerator. That's not just a single number, something divided by 6. If you don't, your calculator is going to see a plus sign and a divide sign, and it's going to want to divide first. But you're going to have to just remember to insert your own little set of parentheses if you key that in your calculator to come up with these values. That's how you're going to do that. Okay, number 8, let's move on so we can, I'm probably going to cut the video after this and send it, then I'll come up with a separate video for the backside. Well, once again, we need to get it equal to 0, so if we add 9 to both sides, we'll have 0 here, x squared. Let's go ahead and rearrange these things so it's in standard form. Our x squares come first, then our x's, and then our plain integers would be here. And then that means my a value is this little ghost understood 1, my b value is 4, and c is 9. And I'm going to go ahead and write that down. A is 1, b is 4, c is 9, and those are the values that I need to plug into the quadratic formula. So x is equal to the opposite of b, so negative 4, plus or minus the square root of b squared, so 4 squared, minus 4 times a times c, so 4 times 1 times 9. I'm going to need to extend my square root symbol, and don't forget, you have to divide all of this over 2 times the a value, so 2 times 1. Now I'll just go ahead and put 2, save ourselves a step. So x could be equal to negative 4 plus or minus, and now we're going to simplify underneath the radical. So that's 16 minus 36. All that over 2. Some of you may already see what's coming, or you did it on your assignment before, but this is going to end up being negative 4 plus or minus the square root of negative 20. And that ought to raise your eyebrow right there, because if you remember, we recall that you cannot take the square root of a negative value. No number times itself will end up as a negative. A positive number times itself would be a positive times a positive. That would yield a positive. A negative number times itself would be a negative times a negative, and that gives you a positive. It's impossible to multiply a value to itself and end up with a negative. So this is an impossible situation. And so we could say that there is no solution. Now I'm looking back at my notes. Yeah, I'm right. I'm trying to look at a different problem. So we'd say x has no real solutions, because that is just not possible. No real solutions on this one. It's a shame you have to get to this point to realize that, but that's how that is. All right, so y'all want to cut this video and go ahead and send that, and you can go ahead and prepare. I'm going to come in here in just a minute with a separate video, and we'll do the word problems on the back side of this page.